Hi everyone, welcome to our presentation for the MICCAI hackathon. My name is Jianan Chen and my teammate is Jun Ma. Today I'd like to share our thoughts on how to make MICCAI papers reproducible. We created a checklist for MICCAI papers where we focused on both the reproducibility of paper and the completeness of code. We also want to talk a little bit about the unique challenge in making MICCAI papers reproducible when the data cannot be shared. Our checklist is based on the machine learning reproducibility checklist. We also gained a lot of insights from the following work. I will be brief in the sections where we directly quote the machine learning reproducibility checklist and emphasize more on the specific ideas for medical image analysis. First, for methods, we recommend the authors to include a clear description of the mathematical setting, the algorithm, and the model, including the details in each block and module. We also encourage the authors to provide explanations of their evaluation matrix, especially the task-specific ones. Compared with the original ML checklist, in the experiment session, we hope the authors can provide more details of the dataset. For example, how was the image acquired and how was the annotations generated? Did the authors account for inter or intra-observer variability? And so on. It is also very important to include the details of pre-processing and post-processing steps. For example, the algorithms and the parameters for resampling, normalization, and registration. In addition, in training and testing, it is crucial to include the patch aggregation method if the patch-based strategy is used, because medical images are very large and we often need to crop the images into patches or cubes and implement some sliding window method to get results on the whole volume. But we found that this information is often missed in many papers. In the results session, we suggest that statistical analysis should be added in quantitative analysis. And for the qualitative analysis, we hope that there could be visualizations of not only the successful cases, but also failed cases, which is helpful for readers to understand the scope of the method and get some insights about the directions for potential improvement. So here we provide a template for checking the completeness of your code and about how to release it. It is built on the template on papers with code. We added the following considerations. First, it's recommended to add a detailed description of how to prepare the data. For example, how to download the data and organize the folder structures. This is very important as it will save a lot of time for readers who want to implement the code on their own dataset. Again, it is crucial to include the code or at least the description on the pre-processing and post-processing techniques. For instance, in segmentation tasks, some post-processing methods like extracting the largest connected area or removing small objects are used to further improve the performance. This part should be explicitly included. Lastly, we want to discuss how to ensure reproducibility if the data cannot be shared. There are a lot of difficulties in sharing medical data. Therefore, we suggest that authors first search if there is a public dataset available. If there is, please run some experiments on public datasets. Otherwise, we suggest that the authors explicitly claim that there is no public dataset for the given task. In this year's MICCAI, many researchers pointed out that we should avoid a bottom-up approach in creating datasets or challenges. Instead, we should start from the clinical problems and create datasets based on what we need to solve the real problem. We hope that by explicitly claiming the need of public datasets for different tasks, it will benefit the community by setting goals for what data to collect and annotate. Another approach for solving this problem would be creating Docker containers for the proposed models, so that interested readers can directly infer on local data and make comparison with other methods. This process not only makes it easier to share models, but also keeps the privacy of the algorithm and train weights. We want to thank the organizers for organizing this event, and we thank the mentors and keynote speakers for providing valuable advice. Thank you for your attention. You can see the checklist in the URL here, and please let us know if you have any thoughts. Thank you.